Welcome to the deep dive. Today we're doing a really deep technical look at what it takes to build a high-stakes AV system. And we're going to do that by tearing into the core blueprint of one specific device, the PureLink HTX II-8800. It's an 8x8 4K HDMI to HDBaseT matrix switcher. And our mission for you is to understand the architectural decisions that are baked into this almost $3,500 centerpiece.
Exactly. We're not just listing features. We want to get at why it's engineered this way. And at its heart, it's an 8-input, 8-output switcher. So 8 4K sources to 8 different destinations.
Okay, let's unpack that 8x8.
Right. But here's the critical choice, architecturally. The outputs are not all the same. It's a split.
A split. How so?
6 of the destinations go out remotely over HDBaseT, while just two, remain local via standard HDMI output.
Okay, so that's 6-2 split. I mean, that immediately tells you its main purpose, doesn't it?
It does.
Long-distance distribution is the absolute priority here. And for that, you need HDBaseT. It's the tool for the job.
It is. And what's fascinating is the 24-volt power over cable support. Or hosts.
6 of those remote ports.
All 6, which is a huge operational efficiency move.
Right. No local power bricks needed for the remote receivers. That simplifies installation and, I imagine, reduces potential points of failure way down the line.
That efficiency is critical, but that long-distance requirement, we're talking up to 330 feet or 100 meters over standard KT's cabling, that immediately forces a video concession.
A trade-off.
A trade-off, yes. The unit can handle a pristine 4K at 60 Hz, 4.4.4, on the local HDMI connections.
But pushing that signal over 100 meters of copper, you're going to hit a bandwidth wall.
Hit a wall. So it has to perform a conversion. It takes that top spec 4.4.4 signal, and it drops it down to 4K at 60 Hz with 4.2.0 chroma subsampling for the HDBaseT outputs.
And that's the engineering compromise that makes that long-distance 4K run possible.
Exactly. And of course, compliance-wise, it's totally modern. It handles HDMI 2.0B and HDCP 2.2.
Okay, so the video part makes sense. But connecting this to the bigger picture, that's only half the story, isn't it?
It really is. Before we get too lost in video switching, we have to talk about the sound. The audio complexity is just something else.
It seems staggering. Why does an 8x8 video switcher need an independent audio matrix with 22 inputs? Isn't that overkill?
You'd think so, but you have to consider what this thing is built to integrate.
So you've got the 8 audio streams coming in from the HDMI signals.
Right, plus 8 dedicated audio return channels, or ARC.
And on top of that, 6 ports for other external sources.
So yeah, that's 22 inputs, and they can all be routed to 16 independent outputs.
That's the 8 audio breakouts, the 6 HDBaseT lines, and the 2 local HDMI outs.
It's not overkill at all. It's preparation for really complex environments.
Right, so the integrator can use it for more than just the movie soundtrack.
Exactly. Think background music, teleconferencing feeds, paging announcements, all managed separately from the video path.
And it still supports advanced formats like Dolby Atmos and DTS.X pass-through.
It does, and it also includes volume, mute, and even audio delay adjustment, which is vital for fixing any lip-sync issues with LPCM audio.
And to manage all of that, the control options are pretty robust. You've got the front panel, IR, RS-232.
And crucially, LAN and a web GUI.
All packed into a compact 1RU rack-mounted design. So what does this all mean for you listening to this? This device is engineered not just to switch signals, but to basically manage an entire building's distribution ecosystem with minimal failure.
And that brings up the real question. Considering its comprehensive control options and that really impressive 50,000-hour MTBF, that's mean time between failures, the ultimate question for the integrator isn't just about features, it's about the cost of failure.
Okay.
So here's something to think about. When extreme reliability is prioritized above all else in a piece of professional gear like this, how much more pressure does that put on the control software to perfectly manage a device that is, by its very nature, designed to never, ever go down? That's a question worth exploring.